Hi to all. Today I am going to explain applications of total internal reflection. In that first application I am going to explain, that is mirages. Total internal reflection means what? What are the conditions for the total internal reflection? For example, when light ray is trying to move from denser medium to rarer medium, if the angle of incidence is greater than critical angle, then the light ray will be reflected back into the same denser medium. Then this phenomena is called as total internal reflection. And now, due to the total internal reflection, we observe some patterns, and then some applications are there. That applications I am going to explain now. Okay. Now look at here. First application, I gave the heading as mirages. Then what is mirage? Mirage, when it will forms. Okay. And then for the purpose, let us see here. The mirage is an optical illusion. It is observed in hot summer. Right? Mirage, mirages forms in optical in hot summer. In hot summer, we observe these mirages. What is mirage? And here you see, mirage is an optical illusion. Mirage is an optical illusion. You see in the deserts, in the hot summer at long distance, you observe the water, but it will not there. When you will go there, you cannot observe the water. That is a mirage. Mirage is an optical illusion. Due to that, you will feel like that. Okay, it is an optical illusion. Due to the light that will forms, mirage is an optical illusion. Due to that, inverted image of an object is observed at here. Inverted image of object forms. Then how it will forms? You see here, this is the one figure I am going to explain. You see here, there is a tall object. There is a tall object, and one fellow is standing at long distance from the tall object, and he is watching that all tall object. Then we see in hot summer the earth acquires the heat within short period, and it will become warm, and it transfer the heat to the layer of the air which is in contact with the ground. That means the layer which is in contact with the ground, the air layer which is in contact with the ground, it will get the warm first. That means when you go up, the temperature will be decreases. The layer which is in contact with the ground, it will become warm. Okay, and it is at high temperature. Due to that high temperature, okay, the air will be expands, volume increases, density decreases, it has less refractive index. It has less refractive index. Now you see here, this has when you will this is the when you compare these two layers. For example, I am comparing these two layers. This layer is at high temperature and this layer is at low temperature. You see the diagram beside of this member. I am splitting the air above the ground into different layers, and this layer is the lower layer which is in contact with ground is at high temperature. Due to that high temperature, what happens, its volume increases, density decreases, it will act as rarer medium and comparing with the upper layer. That means when you compare any two successive layers, the upper layer will act as denser medium and lower layer will act as rarer medium. Why upper layer is denser medium? Because it has less density and this lower layer has high density. When you will go down, the refractive index is decreases. That means upper layer has high refractive index, lower layer has less refractive index. High refractive index is said to be denser medium, and low refractive index is said to be rarer medium. You see here, this tall object is observed by this fellow, and we are taking one light ray from the top. For example, this is the top of the tree, and from the top of the tree, from the green leaf, one light ray we are taking it here. That light ray, you observe this one, that light ray is passes through the several layers of the air, but the same air, but the different layers will act as different mediums because of change in temperature and change in refractive index. And now, when the light moves from different layers, moves through the different layers of air, and every time the light is traveling from denser medium to rarer medium, that's why it will bends away from the normal. Light bends away from the normal, and due to that, angle will be increases at a particular layer. What happens, the angle of incidence will become greater than critical angle. The light ray undergoes total internal reflection, and you see here in the last layer, which is in contact with the ground, here the light will be reflected coming back and finally reaches the person's eye. And the light ray which is reaches the person's eye, if you do the extension, then for that, these dotted lines, and this is observed that coming from the from a point that is inside the ground. Okay, that means he observed this object inside the ground. Okay, because this light is appears to be coming from inside the ground. You see here, this is the path, like this it is coming, like this it is coming, and this is the path, and you can do the extension for this. When you will do the extension in the back, then it is appears to be coming from the ground. Then this fellow, he observes the inverted image of this object in the ground. Okay, and this is said to be mirage. But he little bit he was confused, and he will when he will go near to the tall tree, and then when he come to this position, for example, the fellow come to this location. When the fellow is comes to this location, at that moment, he will see the original light ray which is coming from the tall tree. It is not reflected, then he can see above the ground. That means, due to the mirages, we observe the inverted image of one object. That means he cannot see the original object, and he will see the inverted image of object that is from the ground. Here what happening it here, why it is observed. Okay, let us see here. I will explain in few sentences once again. When the light when the person observes the tall objects, when the light passes through the different layers of when light passes through the different layers of air, when light passes through the different layers of atmosphere, okay, it bends away from normal. It bends away from normal. Why it will bend away from normal? Because every time it is moving from denser medium to rarer medium. Upper layer will act as denser medium, and lower layer will act as rarer medium, and it bends away from the normal at a particular layer. At a particular layer, at a particular layer, light undergoes total internal reflection. Light undergoes total internal reflection. Okay, due to that, inverted image of object is observed. This light ray which is reflected and reaches the eye, this is appears to be coming from the ground, and he observed the object, that is a tall object which is above the ground. He observed, he see that his it's inverted image, right? Due to that, he see inverted image of inverted image of object. Okay, this is called as mirages. Okay, right. Now, if you have any doubt, you can ask me. I am going to erase this one. You take the screenshot and note it. Now I am going to start the second application of total internal reflection. That is the diamond sparkle. Right? How diamond will sparkle? Diamond has the critical angle 24 degree. That means critical angle depends upon the pair of mediums, that is a diamond and air combination has the critical angle 24 degree. It is very less. That's why there is a chance to total internal reflection in the diamond. Easily the total internal reflection occurs in the diamond. Now let us see here how the diamond they will cut. The diamond cutting is very important. The faces of the diamond they will cut in such a way that the angle of incidence in the light ray must be greater than the critical angle. At that moment, almost at every phase, the light undergoes the total internal reflection, and the total light it will be comes out to through only one or two phases, and that two phases will appear as more brilliance. We see here, whatever that I explained, that is, I wrote on this. You see here, the faces of piece of diamond are so cut. The faces of diamond we are cutting. How that the light entering into the diamond suffers total internal reflection repeatedly at different paces. Okay, the diamond should be cut in such a way that when the light enters through one phase, it should be repeatedly undergoes total internal reflection at the different phases, and finally that light ray comes out through only one or two phases. Due to that phases will appear very sparkle, brilliance, glittering, shining. Then this is the explanation for the brilliance of diamond. This is the second application. I'm going to rub this. You take the screenshot and note it. Now I am going to Now I am going to explain the third application of total internal reflection, then how total internal reflection occurs in the prism and how it is useful for us, that I am going to explain. You see here I give some points below the heading of T, total internal reflection in the prism. That is, the first point I gave that the prism is made with the glass. Generally the prism is made with the glass. The glass air has the critical angle 42 degree. The prisms are used to that deviate the light ray by 90 degree and 180 degree to form inverted image of an object without changing size. We will use the prism. Okay. The third star mark I gave that the prisms are used in two ways. First one to deviate the light rays by 90 degree and 180 degree, and the second one is that to form an inverted image of an object without changing the size. And this can be achieved by right-angled prism. Okay, which type of prism we have to use in order to deviate the light ray by 90 degree or 180 degree or to form inverted image? We have to use right-angled prism. Okay, so let us see here the first one, that is the how deviate in the right side. I gave that the deviation through deviation through 90 degree. Deviation through 90 degree. How we can deviate the light rays with 90 degree? Then for the purpose what we have to do, that I am going to explain. Let us take one prism, right? Okay, let us take one prism. And now this is a prism. I will draw with the blue color line, and that is this is a prism. Okay. Rectangular prism means it makes 90 degree. Oh, it was very difficult to draw the straight line. Okay, even though I will try. This is a prism, and it is a rectangular prism, and here it is 90 degree, and here it is 45 degree, and here it is 45 degree, right? And sum of the three angles, it is a prism. And the next I'm taking the two light rays. Okay, I will take the red lines, and this is the first light ray. It is incidenting like this in straight. Okay, and now this is the second light ray. I will take one more, that is like this, it is incidenting, right? Then after that I want to draw the normal at here, normal to the second surface. And the further we are drawing the diagram at here, for the first surface, for the surface here, this is the air and this is the glass, and the light ray is moving from air to glass at here. This is the air and this is the glass, right? And this is the glass prism. And when light ray is trying to move from air to glass prism, here what is the angle of incidence at here? The angle of incidence at here is 0. Why? Because this is only normal drawn to this surface, and this is only incident light ray, and here angle of refraction is also 0. And now that's why when angle of incidence is 0, angle of refraction is 0, the light ray will travel in the straight line without any bending. But when we will go for the second surface, here the light ray is moving from glass to air. This is air again, right? This is the air, and this is the glass, right? Glass prism, glass prism. Okay, and here we have to draw the normal for the second surface. Here normal means it's a line, it makes 90 degree with the surface. It should be makes 90 degree with the surface. And this is the normal drawn at that point. This is the normal to the second surface. What is the angle of incidence at here? This is the angle of incidence. Here also we draw the normal at here. This is the normal drawn. Okay. The red color one is the incident light ray. It is incidenting like this. Here we have to draw the normal, right? And now for the purpose we will take the black line, and this is the normal drawn. Normal drawn means it's a line, it makes 90 degree with the surface. This is the normal drawn. And now here the angle of incidence is, this is the angle of incidence. Right? What is the angle of incidence at here? This angle of incidence is, it is equal to, according to mathematics, right? And this is 45, and this is 90 again. This is 90, right? And this is also 45. Then from the figure we will get this is also 45, right? Here angle of incidence is 45, but this is more than the critical angle. Light ray is trying to move from rarer medium, denser medium to rarer medium. Here angle of incidence is 45 degree. Here angle of incidence is the 45 degree, but the critical angle is only 42 degree. Right? The light ray is trying to move from glass to air, denser to rarer. Then angle of incidence is greater than critical angle. Then what happens? Total internal reflection takes place. Total internal reflection takes place. Total internal reflection takes place. Then when total internal reflection takes place, then how light ray will travel? The light ray will be reflected like this. Then the light ray will go in straight in downward direction like this. It will go after the reflection, and it will go like this. After the reflection it will go 90 degree, right? Then that means how much deviation will be occurred. For example, this is the first light ray and this is the second light ray, and the first light ray bends by an angle 90 degree, and the second light ray also bends with the 90 degree. If you want the bend a light ray by 90 degree, then we have to use the prism, right? Okay, this is the explanation for that. And the next, let us go for the Another one, that is the I'm going to write how we can achieve the deviation through an angle 180 degree by using the prism, and in this the total internal reflection takes place. Yes, let us start, and I will explain for that. Then it was very easy to explain, and then I will start. I will draw again the diagram. We have to take the prism, and that is a 90, 45, 45. We have to take the prism, and the prism is a right angled prism. Okay. Now, first I will take the prism. The prism will be like this there. This is the prism, and this is these two are 45 degree and 45 degree, and this is the 90 degree. Yes. Now let us take the two light rays. With the red color ink we will take, then the one light rays will be incident like this in the straight, and here we draw the normal at here. This will be the normal, and now how the light ray will be reflects. Here the angle of incidence is again greater than critical angle. Then the light undergoes reflection with the 90 degree deviation. It will comes and it will incident at this location. And here also we have to draw the normal, right? This is the normal run. And again the light ray undergoes the total internal reflection, because here also the angle will become 45 degree. That is I greater than C. If I greater than C, the light undergoes total internal reflection. Again this light ray will undergoes total internal reflection. When this light ray undergoes total internal reflection, it will go back like this. Light ray will come back like this. And that means this is the first light ray and this is the first light ray. It will be reflected and it comes back like this. How much angle it is deviated at here? The light ray which is going forward and it will come back. That means it is deviated by an angle 180 degree, right? Okay. While it is moving forward and it will come back to the reflection. We will take the another light ray, right? And when you take the another light ray like this, and it undergoes the total internal reflection at here. After the total internal reflection, it will come back like this. This is the second light ray and this is the second light ray, right? What happening in the first one, if you see this diagram, and now I'm going to draw one thing, that this is the object, okay? This is O, this is D. But here what happening it here, the first light ray will goes down and second light ray comes up after the reflection. That's when the inverted image will be forms. This will be O and this is D. What happening inverted image of an object is obtained in this case. Right? Okay. About the third application. You take the screenshot and note every point. I'm going to erase. Now let us discuss One more application, that is the fourth application of total internal reflection. Then what is this fourth application of total internal reflection? Now for this purpose what we have to do? Now I am going to explain the fourth application, field of view of a fish. Let us see this figure. Once everyone look at this figure, there is a one fish at h depth. Okay, you see here there is a fish at depth h. It want to see the outside world, which are some it want to see the birds or anything that are flying on the in the air. Okay, that are which are flying in the air. It want to see that all things. And then the fish which is in the water, this is the water. Okay, the fish which is in under the water at depth h, it want to see the outside world in the air. Then it can see through a circle and through a cone, right? And then that circle area, through what area it can see the outside world, that formula I am going to derive. And what is the this is a this is outside world through a cone, right? And this here we turn the cone, and through a cone it will see then what is the vertex angle, and what is the radius of the circle through which it can see the outside world. These are things we are going to discuss. And this is the water and this is the air. For example, the light ray maximum it can incident at an angle 90 degree, right? With the normal, look at here, this is the blue line. Okay, this is the blue line here, and the blue line starts from here, so from the surface of water, and it will go like this, right? And finally it reaches the after the refraction here. This red line is the normal run, red line is the normal run, and angle of incidence at here is angle of incidence at here is 90 degree. When angle of incidence is 90 degree, when angle of incidence is 90 degree, then angle of refraction equal to critical angle, that we know that one already. Here r will become c. And similarly on the left side also light ray is incidenting parallel to the surface of water, and then that means we draw a normal drawn to the surface of water, then angle of incidence will become 90 degree, again angle of refraction is critical angle, and finally c is these blue lines, two blue lines on both sides, it reaches the eye of the fish, and then it can see the outside world through certain area, that is the that appears like a cone. And now I want from the figure, okay, we write something that is I want the area of field of view. Before that, I will write the critical angle. Here we know the critical angle. This is angle is a C. When this angle is a C, okay. When this angle is a C, automatically this angle is also C from the mathematics. When this angle is C, right? From the mathematics at the fish, we are getting the angle as C. When this angle is a C, right? This angle is also C. And here from the figure, okay, for example, this we can take as O, and this we can take as A, and this is B. From triangle OAB, from figure, right, we take the triangle OAB. From that we write tan C is equal to opposite side by adjacent side. Opposite side is R, adjacent side is H. We write R is equal to H tan C, we write R is equal to H tan CV rate. Now you see what is C at here and what is the H at here. What is R at here? First we write the R. R is the radius of field of view. Okay. That means through what area the fish can see the outside world. That is a block color circle is there. Through that circle, it can see the outside world. R is the radius of the circle. R is the radius of the circle. C is the critical angle, and H is the depth of fish. Okay, fish at what depth? Okay, depth of fish. Fish is at what depth? That is the radius. And if you want the area of a field of view, okay, area of field of view. Area means it is a pi r square. Here we write a pi into r is the h tan c, we write. Then h square tan square c, we write. But we know one thing, that is nu is equal to 1 by sin c. Okay. From this, if you want to find out the sin c, then you will get as 1 by nu. From the sin c formula, I want to derive the tan c value. What is sin c in the right angle triangle? If it is c, okay, sin c means opposite side by hypotenuse. And this opposite side hypotenuse is nu, then this we can get as under root of nu square minus 1 from the Pythagoras principle. And if you want to find out the tan c from this, from the triangle, okay, then we will get as 1 by under root of nu square minus 1. Right, this you substitute in above equation. Okay, right, then you will get the area we will get as pi h square into tan square c. But tan square c, if you will substitute it here, we will get pi h square into 1 by nu square minus 1 we will get. That means we will get as area pi h square by nu square minus 1 we will get. This is the formula for the area of the field of view through which the fish can see the outside world. This is the radius formula, this is the area formula. Okay, and next, if you want, in case of water, okay, in case of water, if you want to find out, in case of water, we know, in case of water, right, we know nu is equal to 4 by 3. Okay, and if you want to find out the r value, we will get as 3h by root 7. This is in case of water, radius of the field of view through which the uh, radius of the field of view through which the fish can see the outside world. Fish can see the outside world through certain area. You see here, in the figure, the fish is at h depth in the water. The fish want to see the outside world. The fish can see the outside world through the cone that is there in the diagram. That you see the cone, and the cone outer area, that is the circle area, okay, base, that circle, through that circle the fish can see the outside world. That circle is said to be field of view. This is the field through which the fish can see the outside world. The radius of the field of view formula we got it here, right? That is in equation 1. And area of the field of view also we got as equation 2. And the vertex angle through which it can see the outside world. What is the vertex angle? Okay, if you want to know vertex angle, right, from the figure we write vertex angle, right, vertex angle through which it can see the outside world, that is the 2c, that is the vertex angle, right, and through this angle it is showing the outside world, and this we can take as equation 3. Okay, right, and take the screenshot and note every point. I am going to rub this. And next, one more application I am going to explain. This is very important for the board exam. This is very important for the 3 marks, and that is optical fiber. It is also application of total internal reflection. It is also application of total internal reflection. It is the last application, and it is very important. And this I am going to explain now. Now, what is optical fiber? Optical fiber is a cable which is used to transmit optical signals without loss of energy. Without loss of energy, without loss of any energy, then this cable can transmit the optical signals. Let us see here. I will draw the diagram of the optical fiber, right? You see here, this is the, it has three layers. Okay, it has three layers. This is the outer layer. The outer layer of it is a cable. It has outer layer that is called as buffer. It is called as buffer. The outer layer is called as buffer, and the buffer is inside the buffer. Okay, there is one more layer. The cable has three layers, and that layer is said to be cladding, and inside the cladding there is one more layer. This is called as buffer. Like this, the cable has three layers. Okay, and if we go for the construction, right, construction and working, and it has three layers, right, and that are the three main parts. First one is called as the inner part. Inner part is called as the core, and core is surrounded by a layer that is called as cladding, and the cladding is surrounded by one more layer that is called as buffer. Okay, look at here, there are three layers are there for the cable, and the inner layer is said to be core, and core is surrounded by a layer cladding, and cladding is surrounded by a layer that is called as the buffer. And now let us see, let us go for the one more, one by one, and for the three parts we will discuss. And for the purpose, first, what is core? The core is inner central part of the optical fiber. Okay, core is the central part of optical fiber. Central part of optical fiber. It is made with glass or plastic. And the next, core is surrounded by a layer. It is called as cladding. Core is surrounded by a layer called as cladding. Okay, and the is also, core and cladding both are made with the glass or plastic. The refractive index of refractive index of core greater than refractive index of cladding. You have to select the material of the core and cladding in such a way that the refractive index of core greater than the refractive index of cladding. Then core will act as a denser medium, and cladding will act as rarer medium. Cladding will act as rarer medium. And if we go for this, then how it will be works? Buffer is the cladding. Cladding is surrounded by a layer. It is called as buffer. Cladding surrounded by a layer is called as buffer. Buffer protects the What is the use of the buffer? Only core and claddings are used to transmit the signals, but the buffer protects the optical fiber from external damage. From external damage. Okay, these are the some points in the construction, and let us go for the working. And you take the screenshot. Now let us start the working. Working of optical fiber. Okay, and it works based on total internal reflection. It works based on total internal reflection. Let us see how it will works. Its principle is this one only, total internal reflection. For this, let us draw some diagram it here. This is the core. Core is surrounded by a layer. This is optical fiber. You see here, it has 3 layers, and now you see this diagram, and now this inner part is called as the core. Okay, this is the core, and core is surrounded by a layer that is called as cladding, and the cladding is surrounded by a one more layer that is called as buffer. Here also this is cladding, and this is the buffer, right? Now let us go for the working. We will take one light ray. Okay, and this light ray is allowed to incident at here, right? This is the incident light ray. We have to draw the normal at here, and for that this is considered as the normal. Okay, this is the normal, and this is the normal, and this angle is called as launching angle, that is I suffix L. It is a launching angle. And now the light ray will be bends. It is going from air to some core. This is the core material, and it will bends, and it will bend and it will incident on the interface which separating the two medias, core and cladding, on the surface which on this line it is incidenting. This line separates the core and cladding. Below this line, below this black line, the red line is incidenting at a particular point, and this point below core is there, above that cladding is there. There are different materials, right? And now here what happens, we have to draw the normal here also. This is the normal run, and we have to launch the light ray at, at here at the core in such a way that the angle of incidence on the line which separates the core and cladding must be greater than the critical angle. When the angle of incidence is greater than critical angle, this light ray undergoes the total internal reflection. It will go back like this, And here after that, at every point, one time if the angle of incidence is greater than critical angle, at every point automatically the angle of incidence will become greater than critical angle, and due to that the light ray will be reflects at every point and it will passes like this, and like this it will passes, right? And if we draw the normal at every point, and here also we can draw the normal, here also we can draw the normal, this is the normal and this is the normal and this is the normal, and at every point here angle of incidence is greater than critical angle, here also angle of incidence is greater than critical angle. When angle of incidence is greater than critical angle, the light ray will be reflects, and here the light ray is reflected in the same denser medium and the same core, and it will passes to long distance, and this is the working of optical fiber. Okay. Now if you want to write some information, right, the light ray is made to incident on the surface which separates core and cladding, which separates the core and cladding at an angle of at an angle which is greater than critical angle, greater than critical angle. Then light undergoes light undergoes total internal reflection. Due to that, light travel without loss of energy. Light travel without loss of energy, right? Due to the total internal reflection, as shown in the figure. And here I greater than C is occurs. That's why total internal reflection is occurring. I want the launching angle. With how much angle we have to make to incident the light ray in order to travel without loss of energy. That means total internal reflection. That is sine inverse of root of refractive index of core nu core square minus nu cladding square. This is the formula. And if you want the maximum launching angle, that is IL max is equal sine inverse of root of core square minus cladding square. This is the formula. Derivation will be there, but it is not required for us. You take the screenshot and note it. I am going to erase. Let us see now uses of optical fiber, where we will use this optical fibers. First use is optical fibers are used in decorative lamps. Second use is that optical fibers are used in communication to transmit large number of optical signals without loss of energy. What is first application? Decorative lamps. Decorative lamps means there are some light pipe like this there. This is a light pipe like this. This is a light pipe. and this is there is some source is there right here. This source can throw this here. Light can emit and it can travel like this without loss of energy. It can glow it here, just like this water fountain. How water fountain will be there like that, the decorative lamps. Here there is a this is a light pipe. That light pipe is called as optical fiber, right? Light pipe is a optical fiber, and here the light can transmitted without loss of energy due to the total internal reflection, and at the edge it will the brightness will be there just like transmitting we can see, and due to that it will appears just like fountain. And optical fiber second use is that optical fibers are used in communication. We can change the our voice signals, okay. Our audio signals we can convert into electrical signals, and these electrical signals can be converted into optical signals. And optical signals means light signals. These optical signals can be transmitted to long distances without loss of energy. Then like that we can use in communication also. That means audio or any other signals we can convert into electrical signals, and electrical signals converts into optical signals. Then after that we can transmit through the pipe, and we can transmit so many signals without loss of energy, okay. And then next one is that a third application. Optical fibers are used in sensors to measure the temperature and pressure. Temperature to measure temperature and pressure also we will use optical fiber in the sensors. And the fourth use is that optical fibers are used to measure blood flow in heart attack in heart, okay. And optical last one, optical fibers are used to visual examination of internal organs. If you want to see internal organs, then we can send the light and through the pipes, and then that will be reflected back, okay. Then we through that we can visualize the organs from outside, okay. And these are the applications. Thank you for listening my classes, and subscribe my channel, share to your friends.